All right, guys, so I'm going to cover exponentials and logarithms. So for the Unit 10 problems, if I'm asking you to simplify, we want to multiply everything inside. So what this is going to give you is x over 4, x over 2 is going to turn into x over 2 because we subtract. Y to the power of 3 over y to the negative 2. So 3 minus negative 2 is y to the 5 on top. And keep in mind that's all still raised to the power of 3. So exponents on the outside of parentheses, it's like a distributive property. So that's going to give us x to the 6th, y to the 15th. For B, the fact that I have a negative exponent, that rule for negative exponents means that I have to flip the entire piece that's attached to that negative. So all of this has to get flipped. And keep in mind that this is all over 1. So we're going to take this entire piece and put it in the denominator. And that's going to make this exponent positive. So first, this is going to become 1 over 5x to the negative 2, y to the 3, z to the 4, all to the power of positive 3. So keep in mind, I didn't change anything inside. The only thing I changed was the negative exponent on the outside. So now we have to distribute that power of 3 to everything inside, coefficient included. So that's going to turn this into 1 over 5 cubed, which is 125, x to the negative 6, y to the 9, z to the 12. So the only thing that I have to change here is the negative exponent on that x to make that positive. So that means that that one term goes back up top. So this term is going to go up here. So this becomes now x to the 6th over 125, y to the 9th, z to the 12th. Evaluate without using a calculator. So keep in mind what you need to know is the conversion of x to the power of m over n is the same thing as the nth root of x to the m. So the denominator becomes the root. So this turns into the square root, because it's an understood 2 for square roots, to the power of 64, square root of 64 plus or minus 8. So for the next one, I have a negative exponent. So keep in mind, we can simplify the cube root of 8, which is 2, to the power of negative 2. So there's a negative exponent again. We just talked about that. So I'm going to put this 2 over 1. So because of that negative again, that negative means that I have to flip what's inside the parentheses, or what that negative exponent is attached to. So this is going to become 1 over 2 to the power of 2. Excuse me, that's 1 over 2 to the power of 2, which is the same thing, but I just want to make sure I'm writing it correctly, which is 1/4. Three to the power of negative 3. Negative 3 to the power of negative 3. So negative 3 cubed is negative 27, because 3 times 3 is 9, 9 times 3 is 27, and 3 negatives is a negative. And then since there's a negative exponent, we wanted to take the reciprocal of that. So negative 27 Flipping that is negative 1 over 27. Five over 4 raised to the power of 3, just distributing the power of 3 to both of these. This becomes 125 over 4 to the power of 3. 16 times 4 is 64. Solve the following exponential functions. Keep in mind, if I'm solving an exponential, very similar to logs, is we want them to have the same base. So what I notice is I have a 9 and an 81. I can rewrite 81 as a base 9. It's just a reminder that 81 is the same thing as 9 squared. So working this is 9 to the power of 3x is equal to 9 squared to the power of x minus 4. So once my bases are the same, I can just solve their exponents. So this becomes 3x is equal to 2 times x minus 4, which is 3x is equal to 2x minus 8. So x is negative 8. Same thing with b. I notice I have a 2 and a 16. I can rewrite 16 as a base 2, which is 2 to the power of 4, because 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So this is 2 to the x plus 1 is equal to 2 to the 4th, all raised to the power of x plus 3. Bases are the same. So solving their exponents, x plus 1 is 4x plus 12. This turns into 3x is equal to 1 minus 12 is negative 11. So x is equal to negative 11 over 3. For number 4, when graphing this, keep in mind for an exponential, the parent function, what you have to remember is for an exponential, the parent table is negative 1, 0, 1, and then 1 over b, whatever my base is, 1, and then my base. So b is obviously the base of the exponent. Now, a log is the exact opposite of that, where we flip the tables. So here my base is 1/3. So my parent function table that I'm going to start with is negative 1, 0, 1. Write that a little bit bigger. Negative 1, 0, 1. So 1 over 1/3 is the same thing as 3. So just the reciprocal of 1/3. 1, and then my base, which is 1/3. Now keep in mind, I do have transformations going on here. I have a plus 2 and I have a minus out front. Everything outside of the exponent affects the y's. So my x's are not changing here. So the y's are changing by multiplying by a negative and adding 2. So I'm going to multiply every one of these y's by a negative and then add 2 to it. So negative 3 plus 2 is negative 1, then 1, and then negative 1/3 plus 2 is 1 2/3. So these two columns, because I don't need this anymore, are my new coordinates. So plotting these, negative 1 comma negative 1, 0, 1, and then 1 and 1 2/3. Keep in mind here your asymptote. What you need to remember is the asymptote is just my k value here. So my HA, which is y is equal to k. So in this case, it's equal to 2, so I need to graph that. I'm just going to graph that in highlighter just so we can see it. So that's the line my graph is approaching. And that it will never cross, but it's going to approach, like I said. So working this here, getting all the lines, I'm going to run parallel to that asymptote, but never cross it. So that's what my graph looks like. Next one, my b value is 2 because that's the base of my exponential. So same thing, parent function. So the reciprocal of 2 is 1 over 2, then 1, and then just 2. But different to last time, I have a value in the exponent and a value outside. So both my x's and my y's are changing here. So my x's, same rules apply with transformations, x lies. So I have x minus 3 because it's plus 3. And the y's are changing by subtracting 4. So a half minus 4 is negative 3.5, negative 3, and then negative 2. Subtracting 3 from the x's, that's negative 4, negative 3, and negative 2. So these are my new coordinates. I also know that my horizontal asymptote is going to be at negative 4 here. So I'm going to graph that first. Because that's going to give me an idea of where my lines or where my points should approach and where my lines shouldn't cross. So negative 4 comma negative 3.5, 0.5, negative 3, and negative 2, negative 2. So my graph's going to look something like this. Logarithms, which are the inverses of an exponential. So evaluating without using a calculator. So what we need to remember is log base b of a is equal to x, and that converts to b to the power of x is equal to a. So we can change forms from one form to the other. When I'm rewriting forms, keep in mind the bases should always be the same. So really what this first problem is asking me is 7 to the power of something is 1 over 49. So 7 squared is 49. So that means that this problem is negative 2. If 7 squared is 49, then it must be a negative to give me a fraction. So keep in mind here, a natural log has a base of e. So ln is the same thing as log with a base of e. So really what this is telling me is log with the base of e is something, is some value. So changing this to an exponential, e to the power of something is just e. So that's just going to be 1. Because e to the 1 is just itself. So a reminder that a log that has no base written is an understood 10. So no base equals 10. So this is really log base 10 of 100. So what that means is 10 to the power of something is 100. So x is 2. So log base 2 of 8. So 2 to what gives me 8? That's going to be 3 because 2 cubed is 3. So for this next one, when the base is bigger, you kind of have to think backwards. So what this is saying, like we've been talking about, is 27 to the power of something is 3. So when my answer is smaller and not a fraction, that means that my exponent has to be a fraction. So here, what I want to think about is I want to think in the reverse. So I want to think 3 to what is 27, which is 3. So 27 to the 1/3 is equal to 3. So x is equal to 1/3. So for this next one, I have a fraction, so that tells me that this exponent has to be negative. So think 16 to what gives me a half. So I'm gonna look at that denominator and think first 16 to what gives me 2, and then I'm just gonna make that value negative. So just like last time, think in the reverse. 2 to the what gives you 16, so that's 4. So 16 to the negative 1/4, because the opposite of 4, the reciprocal of 4, and then negative. Because 16 to the 1/4 gives you 2, so then to flip 2, you have to make it negative. So which of the following is undefined? If the a value of your log is a negative, that's kind of your that's your sign that something is undefined. Logs cannot be negative. So that a value cannot equal a negative. So here, this is good because 5 to the power of -1 is a fifth. The third one is good because 5 to the 0 is 1, but 5 to the power of nothing can give you -8, so this is undefined. Because that a value, and what I mean by a, is the number in my log, is this number cannot be negative. So expressing things as a single logarithm, keep in mind adding means multiplying, coefficients turn into exponents, and subtraction means division. So so in this case, what I'm adding is 13 and 65. So combining these, that's the same thing as multiplication. So log base t of 13 times 65, which 13 times 65 is 845. Log base t of 845. So in this case, for the next example, each of these coefficients turns into an exponent on that term. So you have to keep that in mind. So each of these guys goes up top and becomes an exponent. And then I'm multiplying them together because I'm adding again. So taking it step by step, let's change the exponents first. This is going to become log base 5 of x to the 3 plus log base 5 of y to the 4. And like I said, since they're adding, just like they were adding last time, adding means I have to combine these terms. So the two terms on each of the logs, I'm going to be combining these two. Just rewriting them as multiplication. So this becomes log base 5 of x to the 3, y to the 4. So like last example for the next one, I see that I have coefficients. So this 2 and this 2 are going to be moved to the front, or excuse me, they're going to be moved to the exponent. So I'm going to take it step by step. So this is log 3 of x squared minus log 3 of y plus log 3 of 4 squared, which is 16. So I'm subtracting these two terms here in the front, my first two terms. So this becomes division. So what I have here is log 3 of x squared over y plus log 3 of 16. So I'm multiplying x squared over y times 16. So that just becomes log 3 of 16x squared over y. Going the opposite way, I'm multiplying y and x plus 4, so that's going to be addition. So this is going to become log base 2 of y plus log base 2 of x plus 4. There's my numerator. So to write the denominator, it's subtraction, so log base 2 of x to the 5th, but I'm not done. This is just me breaking apart the multiplication. So just keep track of what I was doing is this was my numerator, and this was my denominator. But now what I have to do is move this exponent and make it a coefficient, and then I'll be done. So this is going to become log base 2 of y plus log base 2 of x plus 4 minus 5 log base 2 of x. For the next one, breaking apart all of the multiplication, I'm going to do it all at once here, just like last time. So this becomes natural log, or for instance, or correction, 2 natural log of r, because that's the exponent on that r that goes out front, plus natural log of s minus 3 natural log of t. So keep in mind, well, what we've talked about today is square roots. I can convert this first into log base 7 of x y to the power of a half, converting roots into fractions, fractional exponents. So keep in mind, now I have an exponent, so I know this 1/2 is going to come out front, which is going to be a half log base 7 of xy. So I've got to break apart the xy here. So that just turns into 1/2 times log base 7 of x plus log base 7 of y. So describing shifts here, it's just logs behave the same way as exponentials or as everything. Everything inside affects the x, everything outside affects the y. Make sure that you review your transformation rules. So people are going to think that 2 is a vertical stretch, but keep in mind it's adding. So really what you want to see this problem as is log base 2 of x plus 4 plus 2. I'm going to move it to the back because that's actually my k value. So the plus 4 inside, x lies, that's really a minus, and the plus 2 outside. So these are two shifts. So what's happening is this is a horizontal shift. Plus means I'm going left 4. And then the plus 2 is a vertical shift up 2. So the word problems, make sure that you go back and review the word problems and those equations. So the fact here that they're giving me, they give me my tuition, they give my rate of increase, and they want to know when, that's the big thing there, the tuition is going to reach a 15,000. So keep in mind the equation that I'm going to use is A is equal to P times 1 plus R to the power of T. I'm adding my rate because it's increasing. If it was decreasing, I would subtract. So what I have here is 15,000 is equal to 9,410 times 1 plus 0.03, 3% to the power of T. So I can combine this to 1.03 to the power of T. So in order to solve for T, what I want to get is I want to get that base by itself. So I want this term, or what has the exponent, which is just 1.03. I want to get this by itself. So how I'm going to do that is by dividing both sides by my initial. So what I have now is 15,000 divided by 9,410. Which is 1.594 is equal to 1.03 to the power of T. So I can change this to a log in order to get the exponent down. So same thing, this becomes log with a base of 1.03. It should have the same base as my exponent of 1.594 is equal to T. And this I can plug into a calculator. So plugging that into a calculator real quick. That's going to be 1.03. Sorry about that. I was getting my calculator. Of 1.594. So T is going to equal 15.7735. So I'll just say 4. So solving in this case, for number 7, all I have to do here, I'm going to get this out of the way. To solve, I obviously want to get the x by itself. And in most cases, like here, where the log's already isolated, I can find that as a value. So 4 to the what is 64? That's 3. So x is equal to 3. For number 8, 2 to the what is 1 over 8. So it's a fraction, so it's equaling a fraction, which tells me the number has to be negative. So I want to think 2 to the what equals 8. And then that answer, I'm going to put a negative on it. So it's 2 to the third is 8. So 2 to the negative 3 is 1 over 8. Now notice in this case, my a value has the x on it. So I can change this to an exponential to get that 9x off of that log. So this is going to be 3 to the power of 4. Once again, a reminder, when I'm changing from log to exponential, the bases should be the same. So 3 to the 4 is equal to 9x. 3 to the power of 4 is 81. So it's 81 is equal to 9x. So x is equal to 9. When I have a log on both sides, the logs here will cancel. So this problem here really is just 54 is equal to 6x. Which is 9. Same thing if everything has a natural log, the natural logs will cancel and I can just solve their insides. X plus 19 is equal to 5x minus 1. Working this around, 4x is equal to 20. So x is equal to 5. Okay. Make sure you guys, if you didn't understand a certain concept or needed to review it, make sure that you go through your Unit 11 notes and your Unit 10 notes. If you have any questions, please email your teachers. Thank you guys for listening.